Alright, so really this should have been one of the first chapters, like chapter 2, because methods, just like classes, are what the language is all about, but I guess you got to go through things like loops and everything. So learn about methods and implementation hiding. Now you've been writing functions since your first programming language, and a method is just a function. Write methods with no parameters and no return value. Write methods that require a single argument. Write methods that require multiple arguments. Write a method that returns a value. Pass arrays to a method. I don't remember this one. Learn some alternate ways to write a main method header. That one's curious. And learn about issues using methods in GUI programs. Alright, well, we could cover this chapter in 5 minutes, but that's not really what we're going to do. What do I mean by that? We already know how to write a method because a method is just a function. So if you've ever taken Python, C++, Java, you know how to do it. Write a method with no parameters and no return value. Alright, so say we were in some class, inside a namespace, inside a class, and then we needed a method. If it's not going to return anything, you call it void. If you're not going to pass in any parameters, you just don't put anything inside the parentheses. And then inside the body, you do something useful, whatever you were supposed to do. All right, then you can write a method that accepts one parameter. Same deal, void method, and it's going to take something, whatever. This is just a variable definition, like any other variable definition, but it creates a parameter variable, usually just shortened to parameter. And we would be making these static if we were going to be calling these from a static context, like the main method. Since the main method is declared as static, we would have to make all of these static as well if we wanted to call them. So a static method can only call other static methods or access other static members inside the same class. But anyways, the key thing here is just to use the return type followed by the method name, and then inside the parentheses, if there are any parameter variables, you list them. It can get more complicated with that because when you're calling it, you can have optional parameters, or you can have parameters with default values, but that's not really what this chapter is covering. We were going to write a method that took more than one parameter. Alrighty, right? That one accepted 2. And again, it would do something useful with those. Since it's declared as void, it wouldn't return anything. How about writing something that returns a value? Static void, and static is only essential because we're calling them from main. Method 3, whoops, I have 2 method 2s, which is legal, by the way. You can have multiple methods with the same names. That's called overloading. Nothing wrong with having multiple methods with the same names as long as they have different parameter lists. And so this one could take a value and return another one because I changed its return type. It's now no longer returning nothing, it's returning something. Whatever it's supposed to do, right? Maybe it returns x times 2 or something. There. So we have several methods right here. No parameter variables, 1 parameter variable, 2 parameter variables, and 3 parameter variables. Now inside main, invoking the methods. All right, so we have public static, whatever, blah, 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 main, blah, blah. Inside our class, we want to call method 1. Method 1, we've done it. Method 1 did not have any parameter variables, so we did not pass in any arguments. Now we're going to call method 2. It needs a value. It needs an integer or something that can be converted to an integer. It needs a compatible piece of data. Method 3 takes 2 parameter variables. And so it needs 2 integers or values that can be converted to integers. Like if you passed it a character, it would cast that character to be an integer. So you'd wind up with the ASCII value of it. All right. There. Now we have invoked this method. And this method that takes 1 parameter but returns a value. Well, if it's going to return a value, we need to declare a variable that'll accept it. So like int result equals method 4 parentheses, 10, whatever. So when this happened, when it got to this statement, if we were running the debugger on it, it would jump up from here to here. This argument would fill in this parameter variable. And it really is more complicated than 5 minutes, but this part of it that we've shown here is stuff that you already know. And so I don't blame you if you're looking at your phone or whatever while I'm typing about this. But we're going to get into some stuff that not necessarily isn't you've already hit, such as passing by reference as opposed to passing by value or pass by copy. We've seen a little bit of that with the try parse, but you can have reference variables that are defined as in, or reference variables that can be defined as out, or reference variables that are defined as ref. Those have 3 specific meanings. So anyways, when we called method 4 and passed in the argument 10, then x would suddenly equal 10. We would return x times 2, which is 20. So the debugger would bop back down to here, and result is now 20. So if you've ever written a function, you've essentially written a method. A function is just, a method is just a function that's attached to a class. In this programming language, there's no such thing as a function because everything is inside a class, unlike C++ or Python. But like Java. All right, so let's play with the idea of methods, but get into a couple of concepts that are not covered in that little 20-line notepad. I'm just going to make a regular old console application. I believe we're on Lecture N. All right, so I could create a separate class to put my methods in if I wanted to, but there's absolutely no reason to at this stage of the game. So it needs to be declared in parallel with this method. Main is a method just like any other. And maybe you could define a method within a method. I'm trying to think of a way you could do that. You can't do it in Java. You can in Python. Can't think of a way in Java, so you probably can't do it in C#. All right, so we're going to write a function called add, and it just takes 2 methods and returns those values added together. Excuse me, 2 arguments. It does need to be static because it's being called from a static context. So public, although it doesn't have to be public because nobody outside of the program class is going to be calling it. And I don't even have to give it a return type at all if I don't want to. It will default to public. I believe that to be true. It might be private, but it'll still work. So static int add, and it's going to take 1 integer, int I1. Okay, why just add 1 number? Let's add 2 numbers. So int I1 comma int I2. Here's what you cannot do, which I wish you could. Int I1 comma I2, just like when we declare variables. No, each parameter declaration has to be completely independent of the others. All right, and so the result, int result equals I1 plus I2, and then return that result. So if we wanted to call it, we could. Down here in main. Int R1 for result 1 equals add 10 to 20. By the time it's all done, these arguments would fill in these parameter variables. That would be 10, that would be 20. They get copied in there because this is passed by copy, passed by value. How do I know that? Because there's no special word here like ref or in or out to indicate that it's anything other. So by default, C# is doing pass by copy. In some languages, that's all you can do. Python and Java in particular, you cannot pass by anything else other than value by copy. And if I printed out R1, which is no real reason to do, right, then R1 would equal 30. Well, let's write another method. I'm just going to give it the same name because that's legal. I'm going to call it add, but it's going to have 3 variables rather than 2. Well, that's so similar. I'm going to save myself some time and copy and paste it and just change it to have a third parameter variable. So this second method is int I1, comma int I2, comma int I3. So I just changed that line when I copied and pasted it, and I'm going to change this line right here, where the result is equal to I1 plus I2 plus I3. So when we call it, we would feed it 3 arguments to fill in these 3 parameters. Int R2 equals add, right, 10, 20, and 30. Now what about default values? You can define default values, meaning that if you don't pass in an argument to fill that value, it has a default. Now as far as add is concerned, I can't really think of a good default unless we just set them all equal to 0. That would have been a way to avoid having to write 2 different versions of the method. But let's write something that'll print out somebody's name. And if you feed it a last name, great, it'll print it out. If you don't feed it a last name, then it's just going to assume that there is no last name, right? So, Cher and whoever else has only one name, Madonna, don't have to pass in a last name. So this one doesn't need to return anything. So what am I going to declare it as? Void. Static void hello, parentheses, and it's going to accept a first name and a last name. So we need 2 parameter variables. String fname and then string lname. That's an L, not a 1. But we're setting lname equal to empty string, double quote, so that the calling code, the client code, does not have to pass in a second argument if it does not want to. And then so here we're just going to print out CW tab console.writeLine quote hello in let's do it with placeholders. Hello, placeholder 0, space, placeholder 1, close placeholder, end quote, comma, fname, comma, lname, in parentheses, semicolon. Tell you what, just to make it real obvious what's going on here, let's fill in lname at first with a value that's not invisible. What last name are we going to use? We're going to use Chuckles. Everybody's named Chuckles unless we give them a different name. So down in void, we're going to call the hello function. We're going to call it 2 different times, one with only one name and one with another. So hello, parentheses, Madonna. She doesn't like to use her last name. She certainly had one when she was born. So hello, Madonna. And then hello, parentheses, lady, end quote, comma, quote, Gaga. So what's the first one going to print? It's going to print hello, Madonna, Chuckles, because we're not passing in a second argument, so the default value is going to be used. The second call, the second invocation, is going to print out lady space Gaga, because we do provide a second argument. So it's not going to use the default value there. And I forgot to put my read down at the bottom. If I run it without debugging, I can see it real fast. Okay, hello Madonna, Chuckles, and hello Lady Gaga, as promised. So default values can be useful We could have written a function called add that had like 7 different variables, but all of them had default values of 0. So you could just pass in 1 or 2 or 3 or 4, and we wouldn't have needed to write multiple versions of it. Let's write one like that, except it accepts doubles. And so we're going to be a little bit more clever, and it's going to add 3 doubles together and return a double. But they're going to have default values of 0, so you don't have to call it with 3 different. So public double add parentheses, all right, double space D1 equals 0, comma, double D2 equals 0, comma, double D3 equals 0, comma, double, as many as we want, double D4 equals 0. After a while it becomes ridiculous and we probably ought to find another solution. And what does this one do? It just returns D1 plus D2 plus D3 plus D4. And I'm getting a little error about add. Nope, it went away. Good. All right, I better slow down. I'm going to call this double function several different times. Then I'm going to pause, do a walkabout. So double D1 equals add parentheses 1.0 in parentheses. Why did I do 1.0? Just to force it to accept a floating point number. An object reference. Okay, what did I do wrong? It's complaining about something. Look how I defined double and compare it to how I defined, excuse me, look how I compared this version of add to this version of add. There's something different about them. Yeah. For some reason I put the word public in there when I didn't need to, but I didn't put static in there. And as we've said, if you're inside a static context, the only other methods you can access inside that class are also static. All right. So we've added one number. D1 equals add 1.0 to 2.0. D1 equals add 1.0 to 2.0 to 3.0, and so on. We could do all 4 values if we wanted to. So in this case, we're only providing one value, so the other 3 are going to default to 0. Right? We only fill in D1. In fact, we didn't even have to call it with any because there was even a default value provided for the first one. It would have just returned 0, but we could have called double space D1 equals add, parentheses in parentheses. All right, good time to stop. Make sure we're all same place. So what did I just do? While it was paused, I cut static double add and pasted it right above main for the benefit of the people typing in the code here. Now you can also do what's known as named parameters. What do I mean by that? When we call hello, if the parameters are called fname and lname, we could do this. Hello, parentheses, lname equals Jefferson, end quote, comma, and I'm getting an error there, and I'm going to have to figure out why. Fname equals, quote, Thomas, end quote, in parentheses, semicolon. And I botched that, so let me see what I did wrong with the syntax. All right, so there were 2 possibilities here. One is that I had the wrong parameter names. If I came up here, nope, fname and lname are correct. But it's not an equal sign, it's a colon. Equal is for Python. Colon is for C#. There. Now when we call hello, it's going to print out Thomas Jefferson, not Jefferson Thomas, because the first name is Thomas and the last name is Jefferson. Now, is there any good reason to just swap the variable names like that? No, not really. But what if you had a method that had like 6 different parameters and only one of them was required? The first one was required, all the others had default values, but you wanted to specify something for the 6th data type, the 6th parameter. Well, in that case, a named variable is a really useful thing to have, so you don't have to fill in all the other 5 variables in order to get to the 6th one. That'd really be about the only way you could do that. So if we were going to call the double function again, and we wanted to pass in the 1st and the 4th values, we could do that. D1 equals add add 10, and then I'm going to fill in the last parameter with 100. The rest of them would still be 0, so the result of that's going to be 110. In this case, did we need to do that? No, but the parameters were, all of a consistent type and whatever. We could have just passed in 10, 100 and it would work just as well. But the function may have had different types, right? Some strings and some arrays and whatever. And if they had default values that we wanted to skip specifying, then we would use a named parameter in order to pick the one that we didn't want to skip specifying. So what about that out keyword? We've only used it, I believe, in using try-parse. But what it does is it lets you pass in something by reference rather than copy. And what do I mean by that? We're going to write a function, a method, that does pass by copy, and we're going to try to make it change the value inside it. It doesn't need to be anything cool, so I'm going to make it static space, void space, test, parentheses in parentheses. It is going to accept an argument, so we need a parameter variable. And it's space x. And all it does is try to change the value of x. X equals 100. So down here, we're going to call test, we're going to feed it in a value, and then we can print it out, right? So like int x, and then test parentheses x in parentheses. And then if we printed x out, we have to initialize it. I forgot to initialize this, so int x equals 0, semicolon. And then test x, and then console write that value out. Just write out x. It's not going to equal 100. Even though we've gone in here, it's going to bump up to here. X is going to equal 0. Oh, we change it to 100. We get back down here, and no, it's not changed to 100. It's still 0. I really need to put my read line at the bottom. Let's take the time to do that right now. Scroll down to the bottom. This is the end of main. Console.readline or console.readKey, whatever you like. All right. Just trust that that's there. All right, and so it printed out 0. Why? Because this is a pass by copy. X gets copied into here. Doesn't matter that they have the same name. It's like if I have a letter, I hand you the letter, and then if you write on the letter, right? Well, what happened is I didn't hand you the letter, I handed you a copy of the letter because it's passed by copy. So if you tear that letter up into shreds, I still have the original. However, in this language, unlike Python and Java, you can make it so it really will change it. And you use the ref keyword or the out keyword. So if I add the word ref there, and I add the word ref here, Now it's passing by reference. What does reference mean? It means it actually is the object. It's a reference to the object itself. This x is equal to this x, although I've done something bad. Is it ref int x? Yeah, that was it. I got the syntax of that wrong. Ref int x. So, it actually is. In this case, I'm not passing you a copy of the letter. I'm actually passing you the real letter. So if you write on it, you tear it up or whatever, then that's actually changed it for me down here. Now it has some consequences. What if x was a const? Don't type this because it's going to break the code. Why did it break the code? Because the compiler is trying to save us from ourselves. If x is a constant, how could it be changed in here? Can't be. Right? You can't change a constant. So the compiler is saying, whoa, Nelly, don't try to do that. And yeah, you could stick the word const here, and then that line would be an error, or whatever. Or what if you tried to pass in a literal, like this? Well, a literal is also a constant. Don't type this because it's also wrong. Right? I'm trying to pass, the number 1000 in. That's not going to work either. It's 1000. How could it be changed to 100? We're not going to magically go in and rewrite the laws of the universe so that 100 is equal to 1000. Just can't change it, right? So this variable and what is being passed in here have to be of the same type. And you have to use the ref keyword, because if you don't, in this language, unlike C++, you have to tell it in advance that, oh, I'm calling a function with a reference variable. That's what the ref keyword means. Well, Professor, you promised to talk about out. I did. Out means the same thing as reference, except it tells us that the data being passed into it is garbage, that we don't care about it. And so if I change this to out right here, and if I change this to out right here, I would no longer have to initialize that value. And again, I'll probably hit undo a couple of times real fast, so don't make those changes. Right? But even though this is uninitialized, back when it was ref, it complained about it because we were trying to pass something into a reference variable. Well, you better have a value into it before you could do that. But it's an out variable, meaning that he's allowed to change it and pass it back, but he's not going to do anything with it. If we try to do anything with it, if we try to print out x or add something to it or whatever, since it was declared as an out variable, that's not going to work. We have to assign it to something. Then we could change it. And so at this point, WriteLine would still print out 100. So out just means a reference that is output only. And weirdly enough, there's also an in keyword. If you change these outs to in, then it means I'm going to be passing something by reference. I'm passing it in, but I'm signing a contract with myself that that value is not going to be changed. If I change that to in, and I change that to in, it's no longer going to compile. The reason why is because this is trying to change in, and we said that no. X is an input variable only. Even though it's passed by reference, it can't be changed. We can use it, we could print it out, or do something with it, but we can't change it. So if you want a variable that both can serve as input and output into a method, you define it as a ref. If it's only serving as input, you define it as in. If it's only serving as output, you define it as out. That's considerably more fine-grained than what C++ gives you, where you can define something as a reference. The closest you can get to that as C++ is you can define it as a constant reference. But okay, Mr. Professor, why am I going to bother passing it in as an input variable? Isn't that the same thing as just doing this, right? Because it's not allowed to change it, right? We're not going to get a value back out. No, it's not the same thing. What if x was some object that was 5,000 bytes long? Well, if we were passing it in by copy, like this, it would pass in all 5,000 bytes, right? It would have to copy them. That takes time. Whereas if you pass it in as a reference or as an in, then it only passes like an 8-byte address, or however many bytes addresses take up in your operating system. It's far more efficient to pass something by ref rather than pass by copy. So a lot of people write their code to always use refs because it's especially if you're using objects. If you're writing something that accepts an object, you just pass it in by reference. And if you don't want it to be able to change it, then you can define it as a constant reference. I'm getting an error here now. Why was I? Ref int x. Oh, what's wrong with this? I've made so many changes that I lost track of where I was. But maybe you can spot what's wrong.
It's no longer initialized.
Right, x is no longer initialized, so we can't pass it in as a ref. So let's give him a value again. Okay, so the last thing we were trying while I had this paused is that there's another keyword called in. And it's not going to work for me because I'm not using Visual Studio 2018 or 2019 or whatever when it was introduced. I'm using 2013. The way it should work is if you define a word as in rather than out, it means input only, not out, meaning it can't. I wonder if you could change it, but that any changes to it will not affect the variable down here. So if the language worked the way it would on yours, if I passed in x as an input variable, then after we got here, it would always still have its original value because it was input only. This language doesn't have it, so it won't work. If you feel like playing with it, go ahead and look it up. One consequence of it is that if you define something as out, but you do not change it, it considers that an error. Out is a contract saying this function, this method changes that variable. That's the entire reason for that function's existence. And since it's not changing it, we've broken that contract. So if you have an out variable, you better have it set to something. Even if you just initialize it to 0 at the beginning of it, the code's not going to compile otherwise. So why in the world would you want the ability to do that? Besides speed purposes, right? We've already said that passing in something by reference is speedier than passing it in by copy, because when you pass it in by reference, you're giving it just the address of the object rather than making a copy of it. Well, that parseInt is an excellent example of it. If you could either return a value or you could pass a value back out like that, those do exactly the same thing. But you could write a function that returns a true or false based on whether it worked or not. And I can't really think of a good example right off the top of my head, but it would look something like this. Static Boolean, or excuse me, static bool do underscore something, parentheses, and it needs a parameter to do something with it, int x, and it needs an output variable to pass out the result, out space int space y. And it's going to return true if it did whatever it was supposed to be doing successfully. And it's going to return false if it couldn't. Just like try-parse. If you call try-parse and it can't do the parsing, it returns false. So, I don't know. Let's say that if for some reason x is negative, it's going to return false. But it's an out variable, so we better give it some starting value to begin with, no matter what. So y equals, whoops, where'd that come from? Y is equal to 0. We've got to initialize it to something or else it's not going to compile if it doesn't get changed. And then if x is less than 0, we're just going to return false. That's our error condition. You passed in something less than 0, it didn't work. Else, or we don't even need to embed it in an else block, because if it doesn't return, we can set y equal to what we wanted it to do, like the square root of x or something. I don't know. I'm just going to say x plus 1. Who cares? And then return true because we were actually able to do something. So this is almost exactly what try parse looks like, except you pass in a string, and then you pass in an int or a double or whatever, and it returns true if it parsed it successfully, and it returns false if it did not parse it successfully. Now I said that we have to initialize that to 0. Let's make sure that that's true. Yep. What it's saying is that if I got to this point without assigning a value to y, that's error. Because the word out here was a contract stating that we guarantee that this method change sets the value of y. That's what OUT means. If it was just ref, it doesn't have to change it. But out means, yeah, it has to change it, or else it will not compile. All right, so let's go back and actually take a peek at the PowerPoint for a minute, because we made it to page 2. All right, so what is a method? It's a body of code, encapsulated series of statements. When you use it, it's called invoking or calling. Write line is a method. So when you call a method, you use its name followed by parentheses and any arguments between those parentheses. So implementation hiding is an important principle of object-oriented programming, where you keep the details of the method's operations hidden. My add function, you don't know how it works. You don't know that I'm creating a return variable here and then adding some things to it and then returning a result. All you know is what it's supposed to do. It's supposed to add 3 numbers. You don't even care how it does it. I could store those numbers into an array and call a sum function or something stupid like that. You don't care. All you need to know is what you pass in and what you expect to get out of it. And so that's implementation hiding or encapsulation. So the only concern is the interface, the way you work with the method. I don't need to know how it works. I may not have the source code to it. The function itself may be stored in a DLL somewhere, and whoever wrote it doesn't give me the source code to it. So a method that uses another is called the client of the method. Now it keeps messing me up because in the Java class I use the word client and the book calls it the driver. The driver is the client. I like the word client better. When your main here is the client of all these functions down here, right? This is the client code because it uses these functions. Now a function can be the client of another one. If for some reason test needed to say hello, it could say underscore hello, you know. I forget what the name of my function was. It just hello? Yeah, right. So hello, parentheses, you know, and we say Bob, whatever. You don't have to do this. I'm just saying this as an example. So main is the client of the test function, and the test function is the client, one of the clients, of the hello function. Now when you're looking at code, you can jump from function to function. I should call the methods, excuse me. For example, down here, when I'm going to call hello, I can double click on that word, highlight it, and do peak definition. It'll show me what it looks like, right? Peak definition is pretty cool. Or I can double click on it, right click, and do go to the definition of it. There it is, right? It jumped me there so that I could, you know, edit it. I don't need to go fumbling around in all my CPP files looking for it. I just highlight it and double click and say go to definition, and it shows me where it's defined. There was another cool one. Find all references. Well, the hello function's used like 3 times. I do find all references, and here's a list of every time it's called. Hello, Lady Gaga, right? Those are the 3 times it's called. And notice that as I'm clicking around here, I see the code here. It's a very efficient way of finding out where that method is being called, which may be useful information. Like, what if you change that method and you need to make sure that everywhere you're calling it, it's still going to work good? Well, then you could do find all references to it, and you could eyeball it, you know, or you could then add your test code or whatever you needed to do to make sure that all 3 calls to hello functioned as you expected. Of course, if you make a change that breaks the code, it won't compile anymore. Then then you'll have to go and fix it. You don't need to do that. But there are times when it's nice to bop around between all invocations of a method. So methods can be considered a, quote, black box, a virtual device you can use without knowing how it works internally. I have no idea how console write line works, right? Because I don't know what it does to convert those calls into the function calls that'll interact with the operating system to send output to a window. It's a black box to me. So why you use a method? Because the code should be short and easy to follow, and it's easily reusable, right? A method can be hundreds of lines long, and I can just keep invoking it over and over and over. Now all of these functions are like just 1, 2, or 3, or 4 lines long, right? They're not really seriously long. But you certainly can write a method that's, practically an entire method unto it, an entire program unto itself. It could be 2,000 lines long, and then you could call it just with a single word and parentheses, executing all that code over and over and over. So if you ever find yourself copying and pasting code like more than once, consider putting that code into a method. Because if you're calling it more than once, if you're doing that thing more than once in your code, you're probably going to do it a lot more than once. Or you may need to do it more than once in another program, in which case you've already written it and it's real easy. So code bloat, unnecessarily long or repetitive statements. Well, right, my 100-line method, if I was having to copy and paste 100 lines over and over and over to do something useful, well, then my code would become bloated very quickly, right? Second time I pasted it, it'd be 200. Second time it'd be 300. Second time, fourth time it'd be 400 statements long. Those last three those last 300 statements are bloat, because I could have just put those 100 statements in a method and then called them, with a single word. So a method must include the declaration. Some people call it the header or the definition. So it's got a declaration, static void main, right? Or int space add or whatever. That's the method declaration. In C++, you have the idea of a prototype. This language doesn't have prototypes. But if it did, it would be that followed by a semicolon. Well, that's just the header. That's the definition. That's the definition of the method right there. And then you have a body. So in this language, unlike C++, if you try to define a method but you don't put a body, if you just put a semicolon there, I believe it's going to consider it an error. So the method has to include the declaration followed by a curly brace and a body and a closing curly brace. Now technically you could eliminate the body if it was a void function, right? And then you just have a function, a method that did absolutely nothing. That'd be stupid. So you can declare its accessibility, like you can make it public or private. Public means it can be called from any other class. Private means that method can only be called from inside that class. It seems to me like there should be other ones, like only called from within that namespace. There may be, maybe I'm just forgetting. Then there's one called static. We're not ready to talk about that. Then there's the return type. Some of our functions were returning int, some were returning double, and some were returning nothing, void. You have to give it a name, also known as the identifier. You have to give it the parentheses and an optional list of parameter variables, and then a clothing parentheses. I think I said clothing, closing. Like this. You usually try to put your header on a single line unless it's absurdly long. I think we're about done. I think we're going to stop at this slide. You could put private or public there. If it's omitted, it defaults to being private. That's different from Java, where it defaults to something almost public. And then optional static modifier. Right now we're making them all static so that we can call them from main. The method return type, well, that certainly is not optional. The identifier is not optional. The parameter list is optional. If your method needs parameters, you fill them in there. Then the body is not optional, right? You got to have your braces with your stuff there. All right, so the homework's going to be somewhat silly, but we've just introduced the concept of methods. You know, I could make it harder with defining, you know, out variables and ref variables and whatever. So we're just going to write, I'm going to give you the definition of some methods and ask you to write them. So write a static void method, or static method. All of these are going to be static methods. Write a method named convert or kilogram to LBS that accepts a double as a parameter and multiplies that parameter by 2.2 and returns it. Now this is not the exact way you convert kilogram to pounds, but close enough. So what type does it need to be? If it's going to return something and it's accepting a double, probably ought to return a double. So make its return type to double. All right, then write a method named swap that accepts, write a void method named swap that accepts two reference parameters of type int. It should swap, let's just call them x and y, type int, comma, x and y. The body of the method should swap those values. Don't need to return anything because it's a void method. That's probably enough. Except for a named parameter. I'm willing to leave that off at this point. All right. And then write code that uses those methods and prints the results somehow. Right, so if x is 10 and y is 20, we might tell them that, and then afterwards we might print the new values out. So like before swap, comma, x is 10 and y is 20, and then after swap, x is 20 and y is 10. That would show the second one. The kilogram to functions, we would say something like kilograms equals 10, so pounds equals 22. Don't care if you use input statements or not. That makes sense? You're going, no, I don't know how to do it yet, but yeah, I think it makes sense.